We're going to do example number 1 from 3.4. And one suggestion I'd like to make to you guys, I realize that we record the videos here first hour, and that's okay. You know, if you have a question, I don't mind answering the question. I can always pause the video if I need to. Sometimes the question you have is important and I want to include it in the video. And so when we get started, just raise your hand and say, Mr. Adams, I have a question. Ask right then and there. Don't wait till the end because it's better to answer the questions right then and there. So the first thing I want to do, before we do example number 1, is I want to talk to you guys about the properties of logs. So the properties of logs, alright, the properties of logs, the first one is the product rule, okay? So the product rule, it's a shortcut. Now we're going to use all these, so you guys need to write all these down. And so our homework is going to be easy. The homework is going to give us like a story problem, and the story problem is going to have the logs written in a certain way, and we'll find that if we apply one of these properties, it makes it easier for us to make the calculations. So if I have log base B of RS, right, that's a product, R times S, that's the same as log base B of R plus log base B of S. Okay? So somewhere in your homework, you're going to have something presented in this way, and you're either going to take the sum of two logs and make it a product, or vice versa. You're probably going to go this way. All right? So that's the first one. The second one is the quotient rule. So the quotient rule is very similar to the product rule. Okay? And that one is this, that if you have the log base B of R over S, that's equal to the log base B of R minus the log base B of S. Okay? And that's in addition to all the rules that we've learned before. The next one is the power rule. Now the power rule that's if you raise something to a power. So this one we already know because Mr. Adams has already kind of taught it to you. If I have R raised to some power of C, well, we could take that C and toss it to the front. So it's the same as C times the log base B of R. Okay? Does that make sense? Give you guys a second to write that down. This is in your book on page 310. Right? That's on the book, page 310, right? Okay. So now, for example number 1, we're asked to prove the product rule. Okay? And so the product rule is this. If I have log base B of RS, then it should be equivalent to log base B of R plus log base B of S. Now, one thing I want to remind you guys is whenever we have the log base B, all that stuff, remember this. Remember that when I have log base B of X, that's equal to Y, that is that relationship can be represented in this way as an exponential. So they're exponentials and logs are inverses of one another, and that's the mathematical relationship between all those variables. And so we want to keep that in mind as we go to do this proof. So now if this is the case, if that's the case, then RS, let's define what some of these things are. So if I use that property, then technically like R is equal to B to some variable, and I'll just call that variable X for now, right? We don't know what it equals, so we'll just call it X for now. And then S is equal to that same base raised to a different power possibly, which could be Y. So now what that means is that R times S is equal to B to the X times B to the Y. And where this comes from is that we're assuming that log base B of R is equal to some variable X, and log base B of S is equal to some variable Y. So we're just letting X and Y. I don't want the X and Y part to confuse you. It just seems in algebra that's the first place those are the first two letters we choose to represent something. So log base B of R represents a number, and I don't know what the number is yet, so I'm just going to call it X. Okay? And same with log base S. We don't know what that is. We're going to call it Y. And so if this is the case, then this is the same because they have the same base. I would say R times S. Can I do this as a shortcut? Can I do that? Right? Doesn't that mean the same thing? If we were to plug in some numbers, we would add the numbers. Now, if I were to take the log of both sides, watch this, if I were to take the log of both sides, oops, I went up too high. All right, if I were to take the log of RS, so if I were to say log base B of RS, whatever I do on one side, I have to do on the other. And I were to say log base B of B to the X plus Y, right? Is that right? Can I do that? What do you guys think? Yes, you can. So now if that's the case, what happens with the B's on the right-hand side? They cancel, right? And so when they cancel, in other words, we know that this is just going to be X plus Y, right? In other words, that log base B of RS is equal to XY. Is that true? I mean, everything I've done is based on the properties of exponents and logs, right? Everything's valid. Now, if I just knew what X and Y meant, oh wait, I do. Doesn't X equal this? And doesn't Y equal that? So if I come down here, what does that mean? That means that log base B of RS is equal to log base R plus log base B of S. Done. That's the proof. So that's where that comes from. And if we were to do something similar for the other two proofs, we get the same exact answer. In fact, if we were to do the quotient rule, when we were to do our little, at this point here, if we were to do the quotient rule, in other words, we had R divided by S, and that is very sensitive today. if we were to do r divided by s right here, it would be x minus y, so you'd have x minus y, and that's where you get the quotient rule from. And then if we were to do the power of a power, you would see that that becomes a scalar. So are there any questions about what we just did? Does it make sense?